Peace be unto you and your family. 12th Chemistry Refresher Course Model Unifying Terminology in Thermodynamics. Dynamic means flow, thermo, heat energy. It deals with the flow of heat. After discussing all the points in this video, finally we come to know about system and surrounding, how to classify the system and thermodynamic processes, state 4 laws of thermodynamics, establish the relationship between thermodynamic state functions, internal energy, enthalpy, entropy and Gibbs free energy, establish the link between delta G and spontaneity and the relationship between delta G and equilibrium constant. Come to first introduction part of this video, thermodynamic. The term thermodynamics means flow of heat. It is a branch of science which deals with the relation between energy, heat and work. The main aim of study of chemical thermodynamics is to learn transfer of energy from one form to another form, utilization of various forms of energies. First, we are going to know about the basic terms used in thermodynamics. One is system. Any part of the universe under consideration is called a system. Second one is surrounding. Everything in the universe that is not the part of the system is called a surrounding. Boundary. Anything which separates the system from its surrounding is called boundary. Types of systems. Based on physical and chemical properties, systems are classified into homogeneous and heterogeneous. Homogeneous system, all constituents are in the same physical state. A tumbler containing liquid, only in liquid state. A balloon consists of only air. All air is a mixture of gases. Heterogeneous. All constituents are not in the same physical state. When oil mixed with water, oil form upper layer, water form lower layer. Based on the nature of boundary, the system is classified into open system, closed system and isolated system. In open system exchange both energy and matter with its surrounding. Closed system exchange only energy but not matter. In isolated system, exchange neither matter nor energy. A liquid, a hot liquid is taken in a thermos flask is an example of isolated system. Come to thermodynamic processes, very easy processes. First one is reversible process. The system and surrounding can be restored to the initial state from the final state without producing any changes in the thermodynamic properties of the universe. Irreversible process, the process in which the system and surrounding cannot be restored to the initial state from the final state. Adiabatic process, no heat transfer takes place. For adiabatic process, Q equal to 0. Isothermal process, temperature remains constant, dT equal to 0. Isobaric process, pressure remains constant, dP equal to 0. Isochoric process, volume remains constant, dV equal to 0. For cyclic process, the system returns to its original state after completing a series of changes is called cyclic processes. Spontaneous processes, a process which occurs without any external input to the system is called spontaneous processes. Thermodynamic properties. What are the types of thermodynamic properties? One is intensive, independent of the quantity of the material. Intensive, in. Example, density, molar volume. Extensive properties, directly proportional to quantity of matter. So, intensive properties depends on, independent on mass and size of the system. Extensive properties depend on mass and size of the system. Example, the properties mass and volume. State functions. depends only on initial and final state and not on the path followed. Example, internal energy, enthalpy, Gibbs free energy and entropy. Path function depends only on path followed. Heat and work, these two only are the example of path function. All other quantities used in thermodynamics are example of state function. What is meant by internal energy? What is meant by internal energy? U. Internal energy of a system is equal to the energy possessed by all its constituents. U equal to translational energy, vibrational energy, rotational energy, bond energy, electronic energy and energy due to interaction or change in internal energy equal to Q plus W. Q is heat and W is work. Enthalpy H. The sum of internal energy and pressure volume work. The sum of internal energy and pressure volume work is called enthalpy, or delta H equal to delta U plus P into delta V, or delta H equal to delta U plus delta NGRT, P into delta V equal to delta NGRT. Entropy, yes. A measure of randomness or disorder of the system is called entropy. Entropy was introduced to predict spontaneity of a process. Gibbs free energy G. It is the maximum work done by the system is called Gibbs free energy. According to second law, enthalpy is not completely converted into work. The amount of energy wasted is given by entropy and temperature. Thus, the amount of heat energy of the system that is completely converted into work is given by G. G equal to H minus Ts at constant temperature. Delta G, change in free energy equal to change in enthalpy minus T into change in entropy. Standard free energy change and equilibrium constant are related by the equation delta G naught equal to minus RT log in K equilibrium. Now come to the thermochemical equation. A thermochemical equation is a balanced stoichiometric chemical equation that includes the enthalpy change delta H specified with the appropriate sign and unit. When the chemical reaction is reversed, the value of delta H is reversed in sign with the same magnitude. For example, 2H2 plus O2 gives 2H2O delta H0. Standard enthalpy change of a reaction equal to minus 967.4 kilojoule if the reaction is reversed. 2H2O gives 2H2 plus O2. There is no change in the magnitude of delta H value. Sign changes. The negative sign of delta HR indicate that the reaction is exothermic and the positive sign of delta HR indicate that it is an endothermic reaction. Come to the laws of thermodynamics. Zeroth law. When two systems are separately in equilibrium with a third system, they are in equilibrium with each other. First law, energy can neither be created nor destroyed but may be converted from one form to another form. Second law, entropy statement. A spontaneous process is always accompanied by an increase in entropy. Kelvin blank statement. It is impossible to take heat from a hotter reservoir and convert it completely into work by a cyclic process without transferring a part of that heat to a colder reservoir. Glacier statement. It is impossible to transfer heat from a cold reservoir to a hot reservoir without doing some work. Come to the third law of thermodynamics. The entropy of a perfectly crystalline material at absolute zero is zero. Condition for a reaction to be spontaneous is delta G equal to negative, delta H equal to negative, delta S equal to positive. And my dear students, in this video we discussed the terminology in thermodynamics. Thank you for watching. Thank you very much.